Same deal as last time. Every VCE Methods exam, 2018 to 2025. 16 papers, 268 questions, sorted into topics. Here's the last 2 papers, counted mark by mark. Differentiation still huge, 23%. Add integration, and calculus altogether is just over a third of the whole exam. So today, 5 calculus traps. The ones that quietly cost the most marks, because they're not hard, they're just easy to get backwards. Here's a car's distance over time. Right at this instant, is the car's speed the height of the graph, or the steepness of the graph? Lock in your guess. 3, 2, 1. Steepness. Always steepness. Here, the graph is flat, so the car's barely moving, even though it's already gone a fair way. Here, the graph is steep, so the car is flying, even though the height hasn't changed much yet. That's the whole idea of a derivative. It's not a value sitting on the curve. It's how steep the curve is. Every time you see f prime of x, just read it as, how steep is f, right here. New graph. See this flat spot, right here, where the gradient is exactly 0. Is it a local maximum? Lock in your guess. 3, 2, 1. Check the sign either side instead of guessing. Just left of it, the gradient's positive. Just right of it, the gradient's positive again. It never actually turns around. It just paused and kept climbing. That flat spot is a stationary point of inflection, not a max, not a minute. A flat gradient alone proves nothing. Positive to negative, that's a maximum negative to positive. That's a minute same sign on both sides, and it wasn't a turning point at all, it just took a breath. Say you're maximizing something on a closed interval. You take the derivative, set it to 0, and find one stationary point. Are you done? Is that automatically the biggest value on the whole domain? Not necessarily. This stationary point is actually a local minimum. The real maximum on this domain is sitting all the way out at the right edge, a point where the derivative isn't even 0. On a closed domain, always check the endpoints too, not just where the derivative vanishes. This curve dips below the x-axis for a while. If you integrate straight across, from here to here, does the answer have to come out positive? No. Above the axis, area counts as positive. Below the axis, it counts as negative, it gets subtracted. An integral isn't just area, it's signed area. Spend enough time below the axis, and the whole thing can come out negative. If 2 functions have exactly the same derivative everywhere, are they the same function? Nope. Here are 5 different functions. Every single one has the exact same derivative, 2x. They just differ by a constant, shifted up or down. That's why an antiderivative always needs a plus c. You haven't found the antiderivative, you've found a whole family of them. So, derivatives are steepness, not height. A flat gradient proves nothing until you check both sides. On a closed interval, check the endpoints too. Integrals are signed, not just area. And never forget the plus c. That's over a third of your exam, right there. Now go put it to work. Want to practice more like this? Come find us at examprep.com.au. Real past exam questions, and an AI tutor that walks through it with you, one step at a time. See you there.